In this video, we are going to continue practicing graphing sine and cosine functions with amplitude and phase shifts. So, first of all, the amplitude, well, the A value is right here, and there's nothing there. So that means the A value is 1, so the amplitude is 1. The period is going to be determined by the B value. Okay, the B value is right here. The B value is 3. That's going to determine the period. Remember that the period is always 2 pi divided by the B value. So in this case, that just means that the period is 2 pi divided by 3. So the period is 2 pi over 3. Now here's something I want you to be really careful about. The phase shift. Compare this problem, right now we have sine 3x minus 2. Alright, but I want you to compare that to the problem sine, and I'm just going to throw some parentheses in here and put 3x minus 2 like this. Now one of these has a phase shift and one of them does not have a phase shift. Can you tell which one has the phase shift? Yeah, the one with the parentheses, alright? This is the one that's going to have a phase shift. And to read the phase shift, you would have to take that 3 outside of the parentheses, and it would become, and we'd have to divide by 3, so this would be x minus 2/3. Okay? So my phase shift would be 2 over 3 to the right. But this one does not have parentheses. That means the invisible parentheses are right here. Actually, I'd rather put them right here, if I may. Okay, so the point is that this minus 2 is a vertical translation. It's a vertical shift, not a phase shift. It's outside the function. If it were inside the function, there'd be some parentheses. Okay, so for phase shift, we're going to say none. Alright, there is no phase shift. But there is a vertical shift down 2 because of the minus 2. So down 2. So let's go ahead and draw this thing, starting with the period of 2 pi over 3. So a good place to put my period would be right here. So this would be 2 pi over 3. Now if this is 2 pi over 3, halfway would be 1 pi over 3, or simply pi over 3. Now half of pi over 3 is pi over 6. So I'll have pi over 6 right here. Now if I want to get the thing that goes in the third position, I need to multiply this by 3. So this will be 3 pi over 6. But this reduces down to pi over 2, because 3 goes into 6 twice. So this will be pi over 2. Just clean this up a little bit. Okay, let's see what's next. There is a vertical shift down 2. So let's go ahead and deal with that. Okay, so if I were to go 1, 2, 3. Okay, so I'm going to go ahead and put negative 2 right here. Okay, that is going to give me a brand new midline. So I'm going to go ahead and draw my midline right now. Okay, now the amplitude is 1. So that means it's going to be up 1 and down 1 from here. Okay, so I'm going to go ahead and draw that as well. Alright, so if I go up 1, that would be right here. And if I go down 1, that would be right here. Now these numbers need to be labeled. Very important. Okay, so this is -1 and this is -3. Your highest point and your lowest point must always be labeled. Okay, and now we are ready to draw this function. So this is the sine function, and we know that the sine function starts off at the midline, so right here at -2. And then it goes to its highest point, and then it falls back to the midline, and then it goes to its lowest point and back to the midline. Now, since there is no phase shift, this is actually the final answer. Alright, so the final answer is going to just look something like this. Alright, and that is it for problem number 17. Alright, problem number 18. Okay, the amplitude is right here. There's no number there. My A value is 1, so my amplitude is just going to be 1. Now I see the parentheses and everything. My B value would go right here. Since that B value is 1, that tells me that the period is going to be 2 pi. The phase shift. Because there's no B value other than the number 1, the phase shift is going to be this H value right here. So the phase shift is 3 pi over 2. And when it's minus, that means it is to the right. If this had been plus, this would say left. And we also have a K value, which means that there's going to be a vertical shift down 1. Alright, let's start the graph with the period of 2 pi. This would be a convenient place to put the period, because then I can say, alright, halfway would be pi. Half of that would be pi over 2. Alright, and in this position should be 3 pi over 2. Okay. Now, there is a phase shift. I'll worry about that later. Let's go ahead and deal with the vertical shift first. Alright, so there's a vertical shift that's going to be down 1. Okay, so here I am at -1, and you know what, I keep threatening to cheat, and I think I am going to cheat this time. I'm going to use the computer to draw this line for me. Wow, that was a fail. Okay, I'm using a different computer than I normally do, so I'm not 100% sure how to make this. Normally I'd make this a dotted line. Ha! Maybe I'll make it a yellow line. Okay, that is my new midline. Okay, now the highs and lows. Because the amplitude is 1, then I'm going to have highs and lows like this. If I go up 1, I'm back at the x-axis. If I go down 1 from here, I'm going to be at -2. Alright, so this needs to also be shown. Alright, and just do it because I don't know how to make a dotted line. Now, if there were no phase shift, I would just draw my cosine function. So for a moment, let us ignore the phase shift. Okay, so this is a cosine function. So we know that the cosine function starts off high, and then it goes to the midline, and then it goes to its lowest point, and then back to the midline, and then it goes to its highest point. So this would be the answer if there was no phase shift. Okay, but there is a phase shift. That's 3 pi over 2 to the right. Okay, now that's going to be a pretty big phase shift. Now look at this. Notice that 3 pi over 2 is here. That means when we do this phase shift, each point is going to be moved this far to the right. That is 3 full spaces to the right. So I'm not sure my line is even long enough for that. So to even do this, I'm going to have to stretch this out a bit. Okay, what's the best way? Alright, so I'm going to have to stretch this out as best I can. Even though it looks a little ugly, I'm going to do my best. Okay, so I'm stretching this thing out. And I'm going to need to label these additional points as well. So I think I'll do that now. Okay, all of these, I'm looking at the smallest unit, and that's pi over 2. So this is like 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. So this would be 5 pi over 2, 6 pi over 2, but that would reduce down to 3 pi, 7 pi over 2, and 8 pi over 2, which would reduce down to 4 pi. Okay, so now I've labeled all of these. So now it's time to do the shifting and graph my final answer. So remember, each one of these points is going to be moved 3 whole spaces to the right, because that's how big 3 pi over 2 is. Okay, so of course the first one is going to go right here at 3 pi over 2. Now, the easiest thing to do is probably just to follow the pattern of the cosine from here, instead of trying to do this one point at a time. Okay, so we know that the cosine starts off high, then it falls to the midline, and then it goes to its lowest point, and then it goes back to the midline, and then it ends at its highest point. Okay, so there you go. So that tells you that the final answer should look like this. Alright, there it is. That is the answer to number 18. Okay, I'm going to go ahead and squeeze in one more problem here. Let's do number 19. And that'll be it for this video. Okay, so for number 19, the A value is right there. There's no visible A value, which tells me that the amplitude is 1. The B value, there's no visible B value either. So that tells me that the period is 2 pi. Since there's no B value, I can just look right here at my H value for the phase shift. So this is going to be 5 pi over 6. Because it's positive, that means this is to the left. And my K value of 4 means that there's a vertical shift of up 4. Okay, as I go to do my graph, I'm going to start with a period. And this would be a convenient place to put my period. So this is 2 pi. So that means this is pi. And half of that would be pi over 2. And this would be 3 pi over 2. Alright, now it's time for the vertical shift of 4. So got to be really careful with this. So my vertical shift, so here I go. 1, 2, 3, 4. Alright, so there's my vertical shift of 4 because of the k value. Now the amplitude is 1, so I'm going to have to be really careful with that as well. Okay, so I really need to stretch this out a little bit more. Okay, because the amplitude is 1, so I'm going to have to go up 1 to 5, and I'm going to have to go down 1 to 3. Okay, so these are going to be my highs and my lows. Maybe I'll start with that midline. Okay, so I have this midline here at 4. And then I have these highs and lows. Okay, now there is a phase shift, but we're going to ignore that for just a moment. This is the sine function. So let's see, what would the sine function look like if there was no phase shift? Alright, without a phase shift, the sine function would start here at the midline. So I'm looking at the 4, remember this was a midline. So sine function starts at the midline, then it goes to its highest point, then it goes back to the midline, and then it falls to its lowest point, and then it ends up back at the midline. So this is what the graph would look like if there was no phase shift. But there is a phase shift, and the phase shift is 5 pi over 6 to the left. Alright, we needed to go 5 pi over 6 to the left. Alright, now this is complicated enough that I think it's a good idea to go ahead and make a table of values. Alright, these numbers are going to be very awkward. So since we're going to the left, we need to take each of our original x values, our pi over 2, our pi, our 3 pi, and we need to subtract 5 pi over 6. Okay, so obviously if we do 0 minus 5 pi over 6, that's just going to be negative 5 pi over 6. Alright, now the rest of these I'm going to have to work them out like scratch paper. So for example, if I do pi over 2 minus 5 pi over 6, okay, well I'm going to need like denominators, so I would do 3's. So this would be 3 pi over 6 minus 5 pi over 6, so that would be negative 2 pi over 6. Okay, but that reduces. So this would be negative pi over 3. Alright, 2 goes into 6 3 times. So we have negative pi over 3 for that one. Now, I'm going to do pi minus 5 pi over 6. So if I do pi minus 5 pi over 6, then this would be like having 6 pi over 6 minus 5 pi over 6. So that would just be pi over 6. Alright, so I can just go ahead and put that down. So pi over 6. Okay, now let's do the last couple ones. Alright, so I have to do 3 pi over 2, alright, it's my next one, minus 5 pi over 6. And again, I have to do these by 3's. So that's going to give me 9 pi over 6 minus 5 pi over 6. So that's going to be 4 pi over 6. But this reduces down to 2 pi over 3. Okay, and last one, if I want to do 2 pi minus 5 pi over 6. Okay, I'm going to have to do this by 6's. So that's going to give me 12 pi over 6 minus 5 pi over 6. So that's going to be 7 pi over 6. All right. So these are going to be the new values. So let's try to figure out where they go on the number line. All right, I did a little bit of work off camera. Using a 4-function calculator, I converted each one of these fractions into a decimal approximation. So 5/6 is about 0.8, and of course 1/3 is about 0.3. 1/6 is 0.2 approximately. 2/3 is very close to 0.7, and 7/6 is close to 1.2. So I have these decimal approximations. And also I labeled to the left. If this is pi over 2, then this will be negative pi over 2, and this will be negative pi. So this should help us understand what we are graphing. Okay, so this first value, the point that used to be at 0 is going to be moved to the left until negative 0.8 pi. Alright, so that's almost to negative pi, but not quite. So that's going to be right about here, and so this will be our negative 5 pi over 6. Okay, and then our negative pi over 3, that's negative 0.3 pi. Now this is negative 1/2 pi, so that's negative 0.5, if you will. So negative 0.3 is going to be a little bit less than that, so that would be about here. Alright, so let's go ahead and call this our negative pi over 3. Now positive 0.2 pi, okay, well this is 0.5 pi right here, so 0.2 pi is going to be just about here. Alright, so this will be our pi over 6. Alright, and then our 2 pi over 3, that's about 0.7 pi. Again, this is about 0.5 pi, so 0.7 pi is going to be right about here. Alright, so that's our 2 pi over 3. Okay, and 7 pi over 6, that's approximately 1.2 pi. So obviously this is 1 pi. This would be 1.5 pi over here. So 1.2 pi would be right about here. So there's my 7 pi over 6. Okay, see that was extra tricky because we were moving more than a whole space and we were landing between the spaces. So anytime that happens, you just have to do some scratch paper calculations, and I recommend making a T-chart to keep track of your values. Anyway, so be very, very careful about graphing the first point that we're about to graph, and then the rest of them should follow. I'm suddenly feeling like I should extend this out. So remember, our midline, okay, is here at 4. And then we had our highs and lows at 5 and 3. So I'm just going to extend those out. All right, so let's do it. Okay, so our first point is going to move from here over to negative 5 pi over 6, from 0 to negative 5 pi over 6. So that's going to be here. Now this is the sine function, as we remember from the equation and from the graph that we have. So probably the easiest thing to do is just to go ahead and follow the sine pattern right now. So the sine function starts on the midline, and then it goes to its highest value, and then it goes to back to the midline, and then it falls to its lowest value, and then it goes back to the midline again. Okay, so we just follow the pattern of the sine function. So the final answer should look like this. All right, man, that was a tough one. Okay, the labeling of the x-axis is critical, and the y-axis. All right, if your numbers are not visible, you're going to lose a ton of points. All right, so that's it for number 19. This is a long video. I will see you on the next video.